Hello, welcome back to a new video and the introduction to the Linux command line series. In this one, we're going to talk about pipes. So in the last video, we talked about input and output redirection. We said that each program has three streams of input/output. We had the input stream, standard output stream, and the standard error stream. And we've seen how we could basically read the input from the terminal or from a file, and how we can output the output or write the output to the terminal or to a file. In this video, we're going to look at piping. So piping is essentially treating a program's output as the next program's input. So what this allows us to do is we could chain programs in order to achieve a complex function. So we could get programs that achieve simple functions, but chain them together and execute a complex function. And that's one of the strengths of using Linux and Unix, as we're going to see in a bit, the Unix philosophy. But that's basically the simple idea that we're going to learn about in this video. So if this sounds like fun, continue watching. So just a recap of the last video, we looked at command greater than file that sends it to a file and overwrites anything in the file or appends to the end of the file with a double greater than. A smaller than would bring the file into the command as standard input. A 2 followed by a greater than would only send the standard error to the file and it would overwrite the file. If you use the double greater than with the 2, then you're going to append the standard error to the end of the file. Now this one we didn't look at. This is kind of a weird syntax, but basically what you're saying is, so this part here would say the command standard output, send it to file, and also I would like you to send the standard error along with the standard out. So it's not very intuitive. Let's try it. So to make a command produce both standard out and standard error, I'm going to use the ls command and I'm going to pass a good argument and a bad argument. For instance, f. There's no f here. So this is going to produce cannot access, no such file or directory, and then it's going to also produce good output. So if I redirect just maybe the standard out, then I'm going to be left with this. But if I do and1, which is not a very intuitive way of expressing what you're trying to do, and you look at file, well, you see that in file I have this coming from standard error and then the correct or the standard out basically. In bash, what we're using right now, we have a little handy shortcut to achieve this, which is, I guess, much more, it makes much more sense. So you're saying and you're given a greater than sign. So that would be my personal favorite. I wouldn't be using this one. So we can try the same command, but get rid of this and just put and here. And if just, I'm gonna pick file 2, and if you go less file 2, you see that it achieved the same function. What else is left? I'm gonna start with the most straightforward one, which is this one. So cat and 3 smaller than signs and just say hello world. And that's straightforward. And the last one I'm going to show you is this one. So let's try it. Cat. I'm going to use 2 smaller than signs and no spaces. EOF, end of file. So pay attention, no spaces, EOF. And then I hit enter. And then I'm going to type in hello 1. And then if I keep typing, hello 2, hello 3, until I type EOF. And when I do, I get the input in between the EOF and the EOF printed. I'm going to show you one more thing as just a bonus. If you use cat and you say, I don't know, test, hello, hello, test, do you see the pattern? Try it for yourself. I want to talk to you about the null device. The null device is a device basically that discards all data written to it. So what does that look like? So I have a command here that reports an issue, and say that you want to get rid of the standard error or even the standard out, whatever you want. You can, I'm going to get rid of the standard error. You can redirect it to dev null and that gets rid of it. So that cannot access error is not being printed anymore. Same for if you want to get rid of the standard out and keep the standard error, or you could keep, you could get rid of both. You're basically not really interested in having any output displayed. You're just interested in running the command, which is fine. Sometimes you need to do that. So keep that in mind. Now we'll move on to pipelines and pipes. So I'm going to give you a command that has maybe a big output, like user/bin. There's a lot of stuff in there. So I could do that and view them using the terminal, go up and down with the mouse, or maybe I choose to use the pipe character and use that standard out as input to the next command, which is less. And now I could use the keyboard to go up and down and browse the output. So effectively, I hit Q for quit. Effectively, what happens here, output here is input here. And then I can chain as many commands as I like, given that each command would take in the previous command's output, produce output, and then send it to the next command as input. And this is part of the Unix philosophy. Let me show you what I mean. So the reason we have redirecting input, output, and pipes is because of this thing called Unix philosophy. Unix is the operating system that Linux is modeled after. It was created by Ken Thompson and Dennis Ritchie. And the philosophy here that I want to draw your attention to is make each program do one thing well. Or in other words, write programs that do one thing and do it very well. So your program doesn't have to do a million things, it just does one thing. So that this one thing could be used to build more complicated programs that do a million things. And the second thing is you want to write programs that are designed to be able to work together. So you want to expect the output of every program to become the input to another as yet unknown program. So you want your program to read from standard input, expect its input to come from there so that it could be chained in a pipeline as a filter. We're going to see what that means now. And you want your program to write to standard out so that the next program, possibly a program that hasn't been written yet, like our input reader that we wrote in the last video, you want future programs and current programs to be able to consume your program's output. And you would want your programs to be able to handle text streams, because it is a universal interface. So no binary outputs, nothing of that sort. You receive text, you process the text, and you produce text. Very simple. Let's see how that works in action. So I'm going to show you this file that I have here. It's got apple, banana, apple, orange, banana, apple, pear, banana, banana, orange, apple, apple, pear, banana. All right, so this is some duplication. And we are interested here in building a pipeline where we can basically just get rid of all the duplication and maybe sort them alphabetically and then print the final result. So how do we start? I know that the cat command is able to read stuff from the disk and send it to the terminal or to its standard out, generally speaking. So maybe I could use that command to chain it to the next command. So I'm going to cat file, and I see that file has produced the list. Now I'm going to also look at another command called sort. So let me just check out sort. Sorts lines of text files. Sounds good to me. So I'm going to repeat cat file, and I'm going to pass the result to sort. So I got the list now that was unsorted sorted. So it is sorted alphabetically, which is great because our next command, uniq, let's look at uniq, man uniq, report or emit repeated lines. So it is going to filter adjacent matching lines from input. So you'd have to have your input to the uniq command sorted beforehand, because it's just going to look at the lines adjacent to each other, and it's going to, if it detects any lines that are repeated, it's going to just basically pick one line and then drop the others. So let's try that. I'm going to pass the result of sort that we have over here to uniq. So that did the trick. Now I have apple, banana, orange, and pear. Unix philosophy again, write programs that do one thing and do it really well. Write programs that work together, as we see here, and they communicate using text streams. Notice how I could make the command a little bit more optimized by feeding the file into sort directly without needing cat and then piping it to uniq, and that would produce the same output. All right, so for our next example, I'm going to populate file with the following content. This is a normal piece of text that has punctuation, mixed caps, words, and repeated words. Words should become 1 per line. So I'm going to introduce a bunch of spelling mistakes, and let's see if we can write a program from little programs that we combine together that's going to detect all the words that are in violation, that are basically spelling mistakes. So yeah, word, yeah, why not? Okay, that looks good. I'm going to save it, and then I'm going to come here. I'll cat file, and then I'm going to pass it to tr, which is translate. It's a command line utility that allows me to translate basically characters into other characters. So in order to do any sort of lookup, I'm going to need to have everything lowercase. So I'm translating everything that is uppercase to lowercase. And now I got rid of all the uppercase characters. Now to perform the lookup, I'm going to need 1 instance of each word, and I'm going to have every word on its own line. So to do that, I'm going to convert all the spaces to new lines. So to do that, I'm going to also use the tr command, and I'm going to substitute any white space except for new lines, of course, with a new line. So I'm going to replace every white space with a new line, and that would put each word on its own line. But I still have a problem. Some lines or some words would have like a dot after or a comma. I see there's a dash in between. So what I would like to do is use the tr command again, and I'm going to pass an option here for complement and delete. So you could pass delete, and then whatever you put here, it will delete. But if you pass the complement command, anything is in here is going to be kept, and anything else will be deleted. So I'm interested to keep all the characters from A to Z, and I'm interested to keep the new lines. So if I hit enter, I see everything else disappeared. And now this input is not yet ready to be processed by our dictionary tool. So I'm going to take that input and sort it. So I'm going to sort, and now it's sorted. There's no point in looking up like words 3 times. So to optimize, I'm going to use uniq so that I would have each word just represented once. And then I think I'm ready to do the dictionary lookup to figure out which words are basically misspelled. Now the last piece is the command aspell, which is basically interactive spell checker. And I'm going to use the option or the command list, produce a list of misspelled words from standard input. So this sounds like exactly what we need. So I've typed it before. So we've executed up until here. Now we're going to add a spell list, and if you hit enter, you see become, has, len instead of line, and mixed caps, which isn't a word really, piece, and repeated. So here's a table to basically summarize how to use pipes. You've got the normal or standard way of doing pipes, which is command 1 pipe command 2. It only sends stdout from command 1 to command 2. So stdout of command 1 goes as stdn to command 2. And stderr of command 1 goes to the terminal. And basically this is the default way. Now you could use this symbol that we've seen earlier in the video, 2 greater than and 1, to signal to bash that, hey, I'm interested in combining my standard output and standard error in one stream. So your command 1 would have one stream for both. So the piping would actually pipe both standard out and standard error to the next command. So what reaches command number 2 is standard out, standard error. Where does stdout goes? Both actually would go to cmd2. Standard error, none is left. It doesn't go to the terminal or anywhere. And it's a classic pipe everything pattern. There's also a I guess, a shortcut or a nicer way of doing it that makes more sense, which is to use a pipe and then and that would send both and does the same thing basically. And that would cover 95% of the usages that you might want. But what if you just want to pipe the standard error, not the standard out? How do you do that? All right, now we're going to use something called process substitution. And we're going to, I'm going to produce a command here that would produce both stdout and stderr, okay? Now we're only interested in piping this, say to less, and leave out this. So how do we do that? If I go the normal way, I'm only going to get the, standard out, not the standard error. And doing this or this doesn't work, no. So what do we do? I'm going to use process substitution by doing this and a greater than sign before, and also I'm going to replace this with 2 for standard error, and then I'm going to get rid of standard out by using 1 and greater than, and I'm going to send it to dev null, and this way I get standard error piped to less and I don't get standard out piped. And I'd say this is enough for this video. In the next one we're going to look at grep wc for word count and head, tail, and t. So I will see you in the next one. Bye bye.